So today we will be starting with this new topic, which is bistables. So earlier, whatever we have studied, this logic gates, this adder, subtractor, and decoder and multiplexer, they come under this combinational logic. Okay. So what is a combinational logic? Combinational logic is defined as a circuit in which the output at any instance is only dependent on the input present at that instant. Okay, this combinational, we will say that whatever inputs we are giving, it is only dependent on that, and it is not depending on any past inputs. So that is a combinational logic. And here I will give an example of an old AC. Okay. First, I will tell you what is the difference between combination and a sequential circuit. So sequential circuit, actually it has a memory. So a sequential circuit is defined as a circuit in which output at any instance is depend not only in its present input but also in its past history or sequence of the inputs. Okay. So in difference between this combinational and sequential circuit is that combination only has a input, one input and outputs. Okay. But in sequential, what happens? There is a memory element. So there is a memory, and with that memory, it will also work. Like I give an example of this old AC. Okay, if I give an example of this old AC, if you switch it on, it doesn't have a memory. If you switch it on, it will only start from, if 22 degree is set on this, it will only start from 22 degree. Okay, you have to change the temperature whatever you feel like. If you are feeling hot or you are feeling cold, so you have to change the temperature for this. But if I give an example of a new AC, this type of AC, so what it has a memory element. Okay, if whatever you have set the AC previously, so like if you are feeling very hot and you have clicked on 18 degree, so this 18 degree, it will like if you switch it off and then switch it on, it will remember that earlier you have set it as 18 degree. Okay, so that is a memory element for this AC. Another thing, this feedback is there. Like if is in this old AC, you won't see, like if you switch it on, it won't know what is the temperature of the room or what is the what do you want. But these new ACs have a different features of a feedback. So what do you mean by feedback? Like if you go out to a shop and they ask you the for the feedback, what is the feedback for that? Why do you need a feedback? Anyone, what is
Ma'am,
it?
to know about its flaws.
Yes, thank you. So, what is this feedback doing? It will like if I go to a shop and they are asking for feedback, how was the customer care? How was everything? So, what it is means that it will improve on that work. Okay. Same way in the sequential circuit, I'm just giving you an example of AC. So like we have a fully automatic AC. Okay. So if we switch it on, it will see what is the temperature of the room. And if it is very hot, it will set it to cold. Okay. It will set it to cold. So that is a feedback AC is taking. So that is how this feedback is working. So this AC has a memory, and it is inbuilt in this. Like if it is too hot, it has to do it has to make temperature down, and if it is too cold, it has to automatically set the temperature high. So it has a memory, whatever is the temperature, it has to change according to that. So that is a sequential circuit. So whatever we were studying, like adder, subtractor, decoder or multiplexer, it didn't had any memory element. Whatever we are giving the input, it is only depending on that. It is not depending any in any past inputs. Like it doesn't have a memory. But in a sequential circuit, as we have a feedback and there is a memory element, so it will also depend on the past outputs. Okay. So here we will study about how we are making this memory element. Like for digital electronics, you are using a mobile that has a memory. You are using this laptop that has a memory. Okay. So how you are using those memory, uh, how we are making the basics of that memory. Okay. So here we will study about that. Any problem in understanding this combinational and sequential circuit?
No, ma'am.
Okay. So the examples are counters, registers, etc. And we will study this SR latch. So that is using a sequential logic. Like counters, okay, what we are doing, we are using a counter like in a bank. If you go, or in any place you will go, like in KFC also you go, there is a counter running now. Counter, like first customer, second customer, like that counter is running. So if we stop the counter also, it will show like which was the last customer. And then again, like at the lunch, if we start it again, then it will start from the next customer. Like before lunch it was 10, then after lunch it will start from 11. So it has a memory. So that's why we need a counter, because it has to remember which is the past output. So past output was 10, so the counter remembers that past output was 10. That's why we have to do the next number. So like that counter is working. It is remembering which was the past output, and then according to that it is giving the next output. Like past customer was 10, so it will give the next number of the customer, like it will give 11. So we are using this sequential logic circuits in this counters and registers. So what is the basic for you making this memory element? It is NAND gate and NOR gate. So earlier I said we call this NAND gate and NOR gate a universal gate, because we can make any type of circuit through this. So the basic for making a memory is the NAND gate and the NOR gate. Okay. These things you don't have to remember. You have to just remember the truth table. So for 0 0 we are getting a 1. For 1 0 we are getting a 1. For 1 sorry, for 0 1 we are getting a 1. For 1 0 we are getting a 1. And for 1 1 we are getting a 0. Okay, this is the NAND gate truth table. And this is the NOR gate truth table. Only for 0 0 we are getting a 1. For all other cases we are getting a 0. Okay, this you remember na, NAND and NOR gate.
Yes, ma'am.
Okay. So these are the basic gates. We are using NAND and NOR gate for making our memory. So the basic for this memory is a bistable. What was the first invention for this bistable? Okay. Like we are making an airplane. How do we know that airplane will work? Okay. We first made this paper airplanes. It is like it is flying. From that model we came to know that how the airplane works. Okay, so same way the bistables are the basic of how our memory is working. So bistable has two states. One is logic 0, we call it as set. Okay, other is logic 1, we call it as reset. So these are the two states. The name means that the circuit has two stable states, like one is set and one is reset. That's why we are calling it as two stable states. So there are two types of element. One is last. Earlier a student was asking one. So this bistable, it is also called as latch state. Okay. And one more, there is a clock state. So what is lat state? For example, of our old AC, okay, it won't change the temperature until and unless you change with the remote. Okay, so that is a latch state, like you need some device to change it. Whereas in new AC it automatically changes the temperature. So it means it has a memory and it has a clock. Okay, here we are using a clock, so it automatically changes the state. So we have a memory and we use a clock for changing the state. Okay, so for example of an old AC, it will same way this bistable works. It will remain in a latch state, means original state, whether set or reset, until a signal is applied to it in order to change the state, or until the supply is disconnected. Okay, for a latch state, how we make it, we will put a signal. So that signal is a clock. Originally we have a latch state, so it will remain in the same state until and unless we provide with a clock. Okay, clock means on and off. Like if you are using a bulb, it will remain switched on until and unless you switch it off, or it will remain switched off until and unless you switch it on. Okay, so that is a that state, it remains same until and unless you switch on or switch off the system. So here for switching on and off the system we are using a clock. A bistable thus constitute of simple memory cell because it will remain in the latch state. So like it is not changing. It means what, it has a memory. Like whatever the previous state was, it will remain in the same state. So we will say that it has a memory and it will remain in the same state. So how we are making this bistable latches? We are using NAND or a NOR gate to make a bistable state. So this is a representation of our RS bistable state. We have a set and we have a reset. So actually the name RS bistable state, it is coming from the set and reset. Okay, like earlier also I gave an example, like we are using this toothpaste Colgate. Okay, but the Colgate is so famous that it is using, like some people are going earlier when people were not that educated, we only used to see that Colgate ads. Okay, so if we go to the shop, we will ask for give me a Colgate. We didn't know the term toothpaste. Okay, so we would go to the shop and we will ask for give me a Colgate. Same way, this RS bistable state, we got a name from this set and reset. Okay, so we got a name from the set and reset. That's why it is called S and this is called R. But here the set means 1 and reset means 0. So but here like it will change, we are just giving the name. Okay, like we are doing the photocopy. Okay, so the company was named Xerox. So but that Xerox became so famous that people started calling that photocopy as Xerox. Okay, same way here, because we have a set and we have a reset, because of that this this state we are calling it as RS bistable circuit. Okay, so this is the simplest form of bistable, which is called as RS bistable or SR bistable. Okay, so two inputs are there. We can see two inputs. One is set for S and reset for R, and there are two complementary outputs. What do we mean by complementary? What do we mean by complementary?
Ma'am, set of two, which completes. A complete set of two.
Like we are calling A complement, B complement. What is that complement?
Both makes 90 degree.
Not in geometry, in logic circuits. Like,
Ma'am,
mm,
if A is 0, A complement will be 1. Opposite of.
that, yes, good. So here complement means opposite. Okay, so remember this, two complementary outputs are there, Q and Q bar. Okay, so there is a one rule that Q and Q bar should be opposite. If it is same, then the circuit is completely wrong. So what does this complement means? It means opposite or it means inverter. Here you can see now it is Q and this is Q bar. It means whatever is the value of Q, the value of Q bar should be opposite. If both are coming same, it means that the circuit is wrong or that condition is wrong. Whatever the conditions of input are, that is wrong. Okay. So So logic 1 is applied to the set. It will cause logic Q to become logic 1. This we will see how it is coming. Okay, we will see through the simulation. Here, this statement is again repeated. A bistable will remain in the present state until the application of another input. Like without changing the clock, it will remain in the same state. Okay. But in this bistable, it is also called as latch. Here we don't have a clock. Here we don't have a clock, so this is with a clock it is called as flip flop, but here it is a latch, so it will remain same uh, because there is no clock, so it will remain same only. Okay, so sorry, should go to the next slide. So this is our first bistable state. It is made up of NOR gate. Okay. So this is our first NOR gate and this is second NOR gate. We have put this part as set and we have put this part as reset. Okay. So this is SR latch. Set and reset, it doesn't mean it will only remain 0 and it will only remain 1. It doesn't mean like that. It is just a name. And the output for this part will go back to the feedback of this this first NOR gate, and output for this first NOR gate will go back to the input of this second NOR gate. Okay, so this is how we are making this RS bistable. So here we have four conditions, like two inputs are there now, so the combinations will be 0 0 0 1 1 0 and 1 1. So this is the circuit. So here we can see 0 0 is a memory. So why we are calling this 0 0 as memory? And this last condition, it won't work, and these two functions will work. So I can explain memory only after explaining the second condition and this third condition. Okay, so we will simulate the circuit in Logisim. So if we take this condition, we put S as 0 and R as 1. So we will put S as 0 and R as 1. Okay. So here from the truth table, we'll just open this logic gates truth table. This is a NOR gate. So what is the truth table? We will always start from where we have 0. Okay, so we have a 0 here. We won't see these inputs. We will only see this part. So if we see the truth table, if anywhere we have 0, like here we have 0 0. Okay, so we will see what is here and what is here. So first we will see 0 0. So 0 0 is giving a 1 for this NOR gate. So we have input as 0 0. So this is giving a 1. Okay, then this 1 is going to the feedback of this from the second NOR gate. From the output of second NOR gate, it is going to the input of this first NOR gate. Okay, so here we have reset as 1. So here 1 1, what it will if we have 1 1, then if we see the NOR gate output for 1 1, it is giving a 0. Okay. So we can see the output for 1 1 from this NOR gate, we are getting a 0. So this is the first condition for our NOR gate. Any doubt in this? Again, I will explain this. We will always start from wherever we are getting a 0. So we can see here we have a 0. Okay. So these both are zeros. So we will see the truth table for this NOR gate. For 0 0, we are getting a 1. Okay. So for this 0 0, we will get a 1. So output of this second NOR gate is going to the input of this first NOR gate. So here the input is becoming 1. This reset is 1. We have set to 1. And this input is also 1. Okay, so we will see the truth table for this NOR gate. For 1 1, it will give a 0. Okay, so that's why we are getting a 0 here. So our Q, it becomes 0, and our Q naught, it becomes 1. Okay, that is only explained here in this truth table. If we have set as 0 and this as 1, then Q we will get it as 0, and this Q bar we will get it as 1. See, Q here we are getting it as 0, and this Q naught we are getting it as 1. Okay, this is the first condition. Any doubt in this?
No,
Any
ma'am.
doubt? Okay.
No, ma'am.
So we will see this condition. Okay, why we are calling 0 0 as memory state? Why we are calling it as memory state? We are calling it as memory state because whatever the output is there now, it will remain same. That's why we are calling it as memory state. So this is the condition for 0 1. Okay, then what 0 0 is a memory state. So remember this. Okay, our Q is off, Q is 0 and Q naught is 1. If we do 0 0, it should remain same. That is the meaning of a memory state. Okay, so if we do 0 0, we will see it remains same. Whatever the value of Q and Q bar was, it will remain same. That's why we are calling it as memory state. Okay, any doubt why we are calling it as memory state? Okay, this we have done. It will become clear if we do this third condition. We will see this third condition. Okay, we will set as 1 and this R as 0. So we will set this S as 1 and R as 0. So as I told you, always start with from the 0, 0 wherever we are getting a 0. Okay, so here in the input of first NOR gate, we are getting 0 0. So what is the truth table for 0 0? We will get a 1. So we are getting a 1 at Q. Okay, then this set we have put it as 1, and here from the output of this first NOR gate, we are feedbacking it to the input of the second NOR gate. Okay, so it is becoming 1 1. So it is becoming 1 1. So that if we see from truth table 1 1, we will get a 0 output of the NOR gate. So we are getting a 0 output over here. For 1 1 we are getting a 0, and for 0 0 we are getting a 1. Okay, so this is the second condition. So for 1 0, our Q we are getting as 1, and Q bar we are getting it as 0. Here Q and Q bar we are representing as n plus 1, and we are representing n this Q bar n plus 1 whole bar. Okay, n is just a representation. If there are more number of flip flops, so there will be different Q1, Q2, Q3. So that's why we are just calling it as n. Okay. So for 1 0, q we are getting as 1, q we are getting as 1, and q naught we are getting it as 0. Okay, this you understood. Then again I will tell what is a memory state. Okay, so 0 0 is memory state. So whatever the value of this q and q bar was, it will remain constant. That's why we have written q and q bar. And q n plus 1, it means it is a next state. Okay, so whatever the previous value of q and q bar was, it will remain same. So again, we will do this as 0, 0. So here we can see q we are having as 1 and this q bar as 0. So if we put it as 0, 0, it will remain same. So this is used as a memory state. Okay. Again, I will show you. If we do s as 0 and r as 1, so we can see q we are getting at as 0 because both the inputs are 1, and q naught as 1 because both inputs are 0. Okay, so we will see the memory state. What is a memory state? This s and r both should be 0. Okay, so we will do 0, 0, and we can see it is not changing. This q and q is 0 and this q naught is 1. Okay, and if we do the other state, S as 1 and R as 0, then we can see this Q is 1 and Q naught is 1. So again, we will check the memory state. So if we do 0, 0, these outputs are not changing. Okay. That's why we are calling it as memory state. That is memory state. Whatever the inputs are, and if we do 0, 0, these outputs are not changing. If we do 0 1 and if we again change it back to 0 0, these outputs are not changing. So that is called a memory state. Any doubt in this memory state?
No, ma'am.
Okay, so what if we do 1 1? Okay, here we are saying it is forbidden. So here in this output q and q bar, this q is the main output. So whatever is the value of the value of q is there, that is only the main output. Okay, so here because we are getting a 0 here, so that's why it is called reset. And because we are getting a 1 here at the q, that's why we are calling it as set. So whatever the value of q is, that is the state of the device. Q is the main term. Here it is written. No, it is not written here. So Q is the main output of our device. We won't see Q bar. So Q is 0, it means it is reset, and if Q is 1, then it is called as set. I think it is written wrong here. Here I think it will be logic 1 and this will be logic 0. These notes were not made by me, so sorry for that. I got confused that time, but I thought it might be correct. See, 0 is reset and 1 is set. So logic 1, it means set, and logic 0, it means reset. Like reset means you have to start again. Na? That's why it is 0. And 1 means set means it is on. That's why it is called as set. Then we will see this last condition for 1 1. So if we do this 1 1, this you can see q and this q bar, it becomes off. But we know that q and q bar should be opposite to each other, but here they are remaining same. That's why this condition is totally invalid. Okay. And one more thing, it cannot understand what is the output. So it is like toggling, like it is switching off and switching off. So it is toggling and it is not able to know what is the output. So that's why it is a false condition, and because of that, this condition is forbidden. Some people have done this in logic simulator. Na? There we can see the toggling. Anyone has done in logic simulator? This Mahadevan. Some. Uh, okay. It is there in your mobile. Is there in your mobile now? This bistable state.
Yes, ma'am.
Okay, I will stop sharing my screen. Can you start sharing your screen, and we will show it how it will look. Okay, first see. So for 0, 1, we can see we are getting q as 0 and this as 1. So q is which is q? This is q, na? So q we can say that uh, it is 0. So we will call it as reset, and this q bar is 1. So this system we will call it as reset. Okay, do 1, 0.
1.
Okay, from the second circuit. Okay. Uh, 1, 0 you have done, na? So 1, 0, then this
Q
point is
is
coming.
on.
Hmm.
When
Which circuit you are using? This first one or second one? Use the first
both,
circuit.
ma'am.
Okay. Okay. So here we are getting q as 1 and q bar as 0. Okay. You put set and reset both as 0. You will see that both condition will remain same. Do 0, 0. So see, q is 1 and this q bar will remain same. Do
1,
0,
ma'am.
1. Do 0, 1.
0, 1. Okay.
Hmm. Okay, so if we do 0, 1, this q bar it becomes 1 and q becomes 0. So we can say that our this system is reset. And again, if we go back to 0, 0, you will see the state remains same. Okay, what was the previous state? This remains same. So that's why we are calling it as memory state. And if we do 1, 1, do 1, 1.
1, 1.
So you can see that if you do 1, 1, it starts toggling. Okay, here you can see it is like constantly changing. Actually, it is not able to decide what is the input. So this case is forbidden. Okay, that's why we will say that this state is forbidden. Okay, thank you. You can stop sharing. Any doubt how we are getting this outputs? Any doubt how we are getting this outputs? If you are having any doubt, you can ask. Understood na memory state? What is memory state?
Yes, ma'am.
Yes, ma'am.
Okay, thank you. Then we will do the same circuit with a NAND gate. Okay. This is explained here. So this 1, 1 condition is invalid because this q and q bar it starts toggling, or both the outputs are 0, 0. So q and q bar should always be complementary and 0, 0 is not acceptable. So this case is forbidden for us. Okay. So we will do this with here actually earlier we used S and R, but here because we are using NAND gate, so we have made this S bar and this as R bar. Okay. So this is S naught and this is R naught. Here, this is the difference between this NOR gate and NAND gate. It is a like type of representation. We are just using S bar and a R bar. So here also same thing. We have a set and we have a reset. But here in this NOR gate, this is set and this is reset. But here this one becomes a set and this one becomes reset, and it is represented by S bar and this is represented by R bar. Okay, and this is the truth table. So here we can see 0 0 is forbidden, and this 1 1 is memory, and this 0 1 is our set, and this 1 0 is our reset. So we will see how this condition will work. So we will put this condition 0 1. So I put this 0 and this as 1. So I told you now, always start from the 0 side. That's why I'm telling you, make all the circuits so you will be able to understand properly. Okay, if you don't make the circuit, you won't be able to understand. So whatever you are studying, you try to make those circuits either in this logic sim, or you try to make the circuit in this logic simulator. You will understand the problem easily, how it is working. So I told you we will always start from the 0th side. Okay, so input here it is 0 and here also it is 0. So we will see the truth table for NAND gate. So this is the truth table for NAND gate. Okay, for 0 0 we are getting a 1. So for here for 0 0 we will get a 1, and the 1 from the output of this first NAND gate will go to the input of our second NAND gate. So here we are having 1 1. So if we see the truth table for 1 1, sorry, not this. For 1 1 we are getting a 0. That's why we are getting a 0 over here. Okay. So for 0 1 our Q is 1 and our Q bar is 0. So as Q is 1, that's why we are calling it as set. Okay, that's why we are calling the system as set, because it is only depending in this Q. What is the value of Q? This Q we are getting as 1 and this Q bar we are getting as 0. Okay, so the system is set. We will call the system as set. Then what is the memory condition for this? Here the memory condition for this is 1 1. Okay, memory condition is 1 1. So our value Q is 1 and Q bar is 0. So if we do 1 1, then this state should remain same. So if we do 1 1, here Q is 1 and this Q bar is 0. So it is remaining in the same state. That's why we are calling it as a memory state. Okay. Then we will see this other condition 1 0. So we will put S as 1, S as 1 and reset as 0. So as there are 0 0, and if we see the truth table for 0 0 it is 1. So for 0 0 we are getting a 1, and 1 is going back to the input of this first NAND gate. So from here S bar is 1 and here the input is 1. That's why we are getting a 0. 1 1 will give a 0 from the truth table. Okay. So we will see that table. S is 1 and R is 0. Then Q is 0 and this Q bar is 1. S is 1 and R is 0. Then Q is 0 and our Q bar is 1. So as Q is 0, so we will call the system as reset. Okay. That's why we are calling it as reset, because our Q is 0. Then we will test this memory state. We are getting 0 1. So Q is 0.
Ma'am,
Hmm.
ma'am, how we find Q, value of Q?
That's what I am telling. Wherever you are getting a 0, you start from there. Okay. S and R, whichever is 0, you will start with there. So we can say this is 0, this is 0. Okay. So we will see the truth table of this NAND gate. So for 0 0, what we are getting? We will get a 1. For 0 0, we will get a 1. So for this 0, 0, we are getting a 1. Okay. And you have to always start from this wherever we are getting a 0. If we do 1, 0, 0, 1, then we will start from here. Wherever we are getting a 0, we will start from here and we will see both are 0. So we are getting a 1 and both are 1. So we are getting a 0. Okay.
Yes, ma'am.
Wherever there So our second condition is this third part is 1, 0. So we will do 1, 0, 1, 0. So we are getting q as 0 and q bar as 1. Then we will test this memory state. Okay, 1, 1. We will test this memory state. So if we do 1, 1, our q is remains same as 0 and q bar remains same as q as 1. So this is a memory state. This 1, 1 is a memory state, means it will remain same. Whatever was the previous output, it will remain constant. So this is a memory state. Okay. And this condition 0, 0 is forbidden. It means this circuit won't work. So if we do 0, 0, so both are becoming 1. Both are becoming 1. It means q and q bar are not complement. So this case is invalid. Or if you do it in logic simulator, it starts toggling because it cannot decide which output to give. Okay. So this state is forbidden. That's why we are getting it forbidden. If you see the truth table for this part and this part, hello?
Yes, ma'am.
Yes, ma'am.
Sorry, the electricity it went off. Just give me 1 minute. Sorry, I don't have a backup. So we will, you understood now what is this RS bistable state? So we will continue this in next class.
Okay,
Okay.
ma'am.
Yes, ma'am.
Just do your lessons and try to complete your assignments and do all the logism circuits. Okay.
Yes. Ma'am, but if you have a doubt in assignment, then can we message you?
Ah, yes. We will keep that for last class. Okay. Whatever doubt you have, we will clear it in the last class or at the end of the class, you can ask me. You have any other doubt? So write your all numbers and leave. Now, Shashank, you have any doubt?
No, ma'am.
Ma'am, in that SR flip flop, will they use NAND gate or NOR gate, ma'am? Which circuit will be inside, ma'am?
Any gate, mostly they are using NOR gate only, but either you can use this NAND gate or this NOR gate, but usually they use NOR gate because this NOR gate that is more stable form, so that's why they use NOR gate.
Okay, ma'am. Thank you, ma'am.
Any other doubt
Thank
is
you.
there?
No, ma'am. Thank you, ma'am.
Okay, you can leave.
Thank you, ma'am.
Thank you to
Thank you,
all.
ma'am.